Okay, this is section 4.4. You should add this to your notes because you don't have enough examples of using the second derivative test successfully. You use it at the end of the chapter, but you really need more examples a little bit earlier. So we're going to find all extrema using the second derivative test. And to use it, we want the second derivative evaluated at our critical number. So that's our goal. Second derivative evaluated at the critical number, and we'll talk about what that means when we get there. So to get to the second derivative, you need to go through the first derivative. F prime of x is equal to negative 3x squared plus 14x minus 15. And there's no place that will be undefined, so we only will find critical numbers from setting it equal to 0. And there's no greatest common factor, so we need to factor this. And I'm going to use the master product method. So to do that, consider ax squared plus bx plus c is a form of a quadratic. I'll write equals 0. And I want to multiply a times c and get that product. So the product p is equal to a times c, the coefficient of the first term times the constant term. And so, I think I'm going to just take that negative out because I usually like having a leading coefficient that's not negative. So I'll factor out a negative first. Negative times 3x squared minus 14x plus 15 equals 0. And I would have got the same product. So 3 times 15 is 45. And I want the numbers that multiply to be 45 but add up to c. So we have negative 5 and negative 9 multiply to be 45. But when you add them, you get negative 14, which is equal to c. So what we do is we use this to expand our terms. So here's our negative going along for the ride, and remember this is the first derivative here. Negative going along for the ride. 3x squared I'm rewriting. Negative 9x minus 5x, that's expanding that term using those coefficients, plus 15 equals 0. And now that I have 4 terms, I can factor by grouping. So I'm going to group the first 2 terms, and I'm going to group the second 2 terms, and I'll just jam a plus in there to make it not look like it's multiplication, because it's not. So we have f prime of x equals negative 3x times x minus 3, taking out the greatest common factor from the first 2 terms. And now I'll do the same thing, take out the greatest common factor from the second 2 terms, and we'll take out a negative 5. Minus 5 times x minus 3 equals 0. Moving up. And now we'll factor out the x minus 3's. So we have f prime of x equals negative. And we have x minus 3 in each of our terms, so now those are gone. And what's left behind is 3x minus 5. So now we're factored. We can divide by negative 1 on both sides, and then the negative will be gone. And we set each of our factors equal to 0. And we get x equals 3 is a critical number, and x equals 5/3 is our other critical number. The other way that you could do it, because it's quadratic, is you could say, all right, or the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that was another option that would lead to these same answers. Now we need our second derivative. So, let's go back and find the form of the first derivative that we want. This form or this form or this form or this form or this form. And I think I'm going to use this one. So f double prime of x is equal to negative 6x plus 14. and I will take f double prime of my critical numbers. So the second derivative evaluated at 3 is equal to negative 6 times 3 plus 14, and that's negative 18 plus 14 is negative. And what that means, if the second derivative is negative, it's concave down. It opens downward. The function that the second derivative came from opens downward. And if it opens downward, then the critical number, where there's a horizontal tangent, must be at the top. So that would be a relative maximum there. So we have a relative max at x equals 3. And then we check the other critical number in the second derivative. And so we get negative 6 times 5/3 plus 14. And the 3 can reduce with the 6. So now that's negative 10 plus 14. That's positive. And if the second derivative is positive, then every value in that interval is concave up, which means opens upward. And if there's a critical number in that interval that has a horizontal tangent, then it's at the bottom, so it must be a relative minimum. So we have concave up. Relative min at x equals 5/3. Okay, I hope that helps. If you have any questions, let me know.